coming to the structure of amines only. That is the last part, we will finish it up. So in the last year we have said you that due to the presence of the lone pair, bond pair repulsion, the bond angle in 1 and 2 degree amines decreases from 107 degree to 108 degree, that is 9.5 degree to 107 degree. Okay, I am sorry. However, in 3 degree amines, listen carefully this one. However, in 3 degree amines, the bond angle is greater than 107 degree. However, in 3 degree amines, the bond angle is greater than 107 degree due to steric hindrance or steric repulsion. We can say that. Due to steric hindrance or steric repulsion, that is a bulky alkyl group. See, you can see it here. That is, this is your 3 degree amines. We can say that. See, the 3 alkyl groups, when they will come closer, they are electron cloud. When they will come closer, they are going to repel one another. Alright, they are going to repel one another. And due to repulsion, the bond angle is again increased. Otherwise, from 1 degree to 2 degree, when you come, the bond angle decreases from 109.5 to 107 degree. But here, the bond angle slightly increases to 108 degree. I think it's clear. Now, next is, in an amine, you can see that if these three groups are different, R dash, R, that is R double dash, we can say that, and it is R. That means, let us say I will take this one as CH3, this one as C2H5, and this one as C3H7, let us say. Alright, and this is a lone pair. So, all the 4 groups are different. So, this nitrogen atom acts as a chiral atom, and it shows chirality, due to which it shows enantiomerism. Alright, due to which it shows enantiomerism, means it behaves as an optically active compound, we can say that. That is 3 degree amines, it acts as an optically active compound. The condition is that all the 4 groups, 4 means including this, that is has to be different. All the 4 groups, that means the 3 alkyl groups has to be different. When the 3 alkyl groups are different, then definitely it possesses the characteristics of chirality. It's not a chiral carbon atom, it's a chiral nitrogen atom, due to which the mirror image is not superimposable, and hence it behaves, it acts as an enantiomers. That means it behaves as an optically active compound, so to say. Clear? Now, next, after that we will come to the how to prepare this amines. The very important one, that is how to prepare amines. We can say that. So, amines can be prepared by nucleophilic substitution reactions. That is nucleophilic substitution reaction. The name of the process is Hofmann's ammonolysis method, and the general name is what I said, nucleophilic substitution reaction. We will be removing what you can say the hydrogen, and in place of that you will see we will be putting the alkyl group. We can say that. Clear? So in this way we will prepare the amines. What I said you, the name of the process is Hofmann's ammonolysis. We can say that. Hofmann's ammonolysis. So what is that? Rx plus H and H2. This is ammonia. When it is heated at 373 Kelvin, when it is heated at 373 Kelvin, what I said, nucleophilic substitution reaction. So what will have, what will have is that this H, as I have already said you, will be replaced by an alkyl group, that is R and H2 and HX. Alright, this further reacts with Rx to form R2NH. This again further minus HX, of course, again react with Rx to form R3N. Alright, again it minus HX, of course, and again it reacts with Rx to form R4N plus X minus. So what you get is that, listen carefully here, when alkyl halide, for example methyl chloride or ethyl chloride or methyl bromide, any alkyl halide, primary alkyl halide, reacts with ammonia in presence of 373 Kelvin, what it forms? It forms 1 degree amine, primary amine. Then it further reacts with alkyl halides to form 2 degree amine. Then it further reacts with alkyl halides to form 3 degree amine. It further reacts with alkyl halides to form 4 degree amine. We can say that. Clear? So in this way, we get different what you can say amines. So hence this process is called as Hofmann's ammonolysis. We can say that. Clear? So here that is exhaustive alkylation is taking place. Alright. But this method, what you find is that in this method, we are getting a mixture of amines. As you can see it here, we are getting a mixture of amines. So hence this method is not suitable for the preparation of amines. Why? Because the mixture of amines which you are getting in 1, 2, 3 and 4 degree amines which you are getting it, it's very difficult to separate one from the other. It is very difficult to separate one from the other. Because the difference in boiling point between these compounds is hardly less than 3 degree Celsius, we can say that. So it cannot be separated by ordinary method. Ordinary method means by fractional distillation it cannot be done. Some special method has to be adapted to separate this particular, what you can say, compound. So hence the yield of the primary amines, secondary amines will be quite less because you are getting a mixture. Yield is quite less. Suppose if you want primary amines, by this method it is not possible. Because we are getting a mixture of amines, so the yield of primary amines definitely will be less. Alright. So hence, for this reason, this method is not suitable for the preparation of amines. If you want primary amines, then what you need to do is that you need to use excess of ammonia. Instead of using excess of alkyl halide, you need to use excess of ammonia. When I use excess of ammonia, the reaction will be favored in the forward direction only. In the forward direction only, and I will be getting only primary amines. I won't get secondary, tertiary and quaternary amines. Alright now? That is, if I use here excess of ammonia, then the reaction will be favored in the forward direction only and you will be getting only 1 degree amine. We can say that. If I want 1 degree amine, by this method. Next is that, by this method, that is aryl amines, means aniline. We can say that. Benzene ring NH2 cannot be prepared because aryl halides. Aryl, if I use here aryl halides instead of alkyl halides, if I use here aryl halides, only I will be getting aryl amines. So aryl halides does not undergo nucleophilic substitution readily, you know that, because aryl halides are less reactive in nature compared to alkyl halides. We have studied already in haloalkanes and haloalkanes. So hence, what you find is that you cannot prepare aryl amines by nucleophilic substitution reaction. That means by this method. So these are the limitations of this method. We can say that. Clear? Now. Next is, we can prepare it by reduction of the nitro compounds. We can prepare it. For example, if I take RNO2 plus nascent hydrogen. Now nascent hydrogen you can use it, you can get it from any reducing agent. You can get nascent hydrogen. That is, you can use here SN/HCl. You can use here zinc and HCl. You can use here LiAlH4 or NaBH4, that's reducing agent, lithium aluminum hydride or sodium boron hydride. You can use nickel, platinum or palladium in presence of molecular hydrogen, which is known as catalytic reduction, you know that. So any reduction can be carried out to get, what you can say, amines. That's oxygen will be removed by hydrogen. That is only known as reduction. So in this way, oxygen will be replaced by hydrogen, we can say that, and hence we get amines. Where this oxygen will go? It will form water. That is 2H2O. So total 6 nascent hydrogen is required in this way. Clear? If you want to prepare, what you can say, aryl amines, for example, what you do is that you take nitrobenzene plus nascent hydrogen under the same condition. Same condition, you can take it, SN/HCl or LiAlH4, anything. For example, you take here LiAlH4. Alright, anything you can take. Or you can take SN/HCl or zinc/HCl. You can also take, that is, SN I have already written. You can take also zinc and HCl. That also will do. Clear? So what I am going to get it? I am going to get, that is nothing but aniline, benzene ring NH2 plus water 2H2O. So here it is 6 nascent hydrogen. It will do. Clear? So in this way you can prepare it by reduction process, or any other amines can be prepared by this method. We can say that. Now next is, you can also prepare it by reduction of cyanides and isocyanides. Already we have done it. That is cyanides and isocyanides. Just let me tell you, that's RCN on reduction plus H2 will give you RCH2 and H2. RCN, alkyl cyanides, plus hydrogen will give you RCH2 and H2. Got it? So how will you get hydrogen? Same thing. You use any reducing agent, or you can use catalytic reduction like H2 in presence of nickel, platinum or palladium. Achha. So RCN plus, again I repeat, plus nascent hydrogen or hydrogen will give you RCH2 and H2. You got it. Similarly, if you use RNC, isocyanide, what I am going to get it? I am going to get, that is secondary amines. Secondary amines. There you got primary amines. Here I am going to get secondary amines. That is RNC will give you nothing but RNHCH3. RNC will give you RNHCH3, that is your secondary amines you will be getting it. So hence let me tell you in short, cyanides or nitrides on reduction gives primary amines. Isocyanides on reduction gives, that is nothing but secondary amines. We can say that. Clear? In this way. So anything you can use it here. For example, benzene ring NC, that is phenyl isocyanide plus nascent hydrogen in presence of LiLH4 will give you benzene ring NHCH3. That is again another secondary amines you will be getting it. So basically what we are doing is that we are using it to convert, generally in exams the question will be coming, convert alkyl halides to amines. So what you will do is that RX plus KCN alcoholic, you got RCN. RCN on reduction will give you RCH2 NH2. Clear? In this way you can convert alkyl halides, any alkyl halides to amines. It can be done. Got it? Reduction process. Now next is the reduction of oximes, we can say, or oximes, we can also say that. That is RCH double bond NOH. This is the functional group of oximes. So that is this is nothing but known as aldoxim. This is called aldoxim. How did you get aldoxim? Because RCH double bond O is what? Aldehyde. From aldehyde we got aldehyde plus oxim will give you what? Aldoxim. If I use ketone plus oxim, it is ketoxim. Okay, in this way. So what will I do? I will go for again same thing, reduction. Now here I can use another one, Na/C2H5OH. I said you, if I use Na/C2H5OH as a reducing agent, let me write it below. So Na/C2H5OH as a reducing agent, if I use it, it is called as Mendius reduction. Alright. Now what I am going to get it? That is nothing but RCH2 NH2 plus this oxygen is there, means water will be formed. Alright. So you can balance this equation. You can put here 4 because here 2 hydrogen and you got it here, that is 2 hydrogen. Yes. So it is nothing but you got RCH2 NH2 and water. Clear? So for example, that is, let us take one ketoxim, that is CH3 C double bond NOH. That is in place of H we are putting another alkyl group. So the name is acetoxim. It comes under the group ketoxim because it is made from ketone. So it is ketoxim. But name of this particular compound is acetoxim. Plus again nascent hydrogen. Again the same thing, reducing agent. What I am going to get it? That is nothing but CH3. Alright. Then it is CNH2. CH3, CH rather, CH NH2. We can say that. It has to be balanced, isn't it? So in this way, plus water. I can write here minus water. So it is a secondary amines, we can say that, secondary amines I am saying, isopropyl amine we got it, as secondary amines we can say that, because the functional group is attached to the secondary carbon atom. Got it? Yeah. So it is isopropyl amines, we can say that. Clear? Now we can prepare from amides also, amides, for example CH3CONH2. This is your acetamide plus nascent hydrogen. So from where will I get? Many reducing agent is there. I have already said it, many reducing agent is there. Here you can use, I am using different reducing agent. You can use the same also, no problem. I am using different because just to show it to you that these are the different reducing agents, so that you can know at least the name of the reducing agent. Otherwise, suppose this only I am using this one only, or I am using SN/HCl. I will get the product, no doubt. But in exam this is coming or this is coming, then you will say what is this? I do not know. For that reason I am writing it out. Okay, the different reducing agent. So here in presence of ether, ether is an inert solvent. But I am going to get it. This oxygen will be removed by hydrogen. It will be replaced by hydrogen. So CH3, CH2, NH2 plus this, it will form water. So here it is 4 nascent hydrogen I am going to get it. That is CH3, CH2, NH2 plus water. That is reduction of that is acetamide, amides we can say that. If you take here benzamide, if you take benzamide, alright, for example, benzene ring CONH2 plus same thing, nascent hydrogen, same thing, same process. What will happen? Benzene ring, you will be getting an aryl alkyl amines CH2 NH2 and water, minus water. This is an aryl alkyl amine. It is otherwise known as benzyl amine. Benzene ring CH2 is what? Benzyl. So you got benzyl amine, so to say. Clear? And aryl alkyl amines. Aryl alkyl amines. We can say that. Clear? So we can prepare it in this way. Next, we can prepare it by Hofmann's bromamide reaction. Very, very important. Very, very important. Hofmann's, we have done Hofmann's ammonolysis. This is another one. Hofmann's bromamide reaction. Hofmann's bromamide reaction. We can say that. Here we are using amides. We will be using amides here. Clear? That is, let us say CH3CONH2 plus Br2 plus KOH aqueous. We can say that caustic potash. We will be using it. So what is going to happen here? Listen very carefully. Here we are having two carbon atoms. It will be reduced to one carbon atom. So this particular reaction generally is used for the descent of series, to decrease the number of carbon atom in what you can say conversion, interconversion. Alright, we are doing a convert this compound to this compound. So like to convert ethylamine to methylamine, you will see it. You will be using this particular one. Ethyl to methyl, to decrease the number of carbon atoms from 2 carbons to 1 carbon, to decrease the number of carbon atoms. This particular compound will be used. Remember it. So Hofmann's bromide reaction is very, very important. It is very important. The thing is that why it is important? Because it is used to decrease the number of carbon atoms. For descending the series, for lowering the number of carbon atoms from 3 carbon to 2 carbon or from 2 carbon to 1 carbon. For that reason we use what you can say, that is Hofmann's bromide reaction, so to say. So what is the product? The product will be CH3NH2 plus K2CO3. We will be getting it. CH3CONH2, so it will be nothing but K2CO3 plus potassium and bromine will form potassium bromide plus water. We can say that. Clear? So in this way you will be getting, that is the Hofmann's bromamide reaction. So any amide you can use. You can use alkyl amide, you can use aryl amide. In all the cases the number of carbon atom is going to decrease. In aryl amide you will be using benzene ring CONH2. So it will be benzene ring NH2. Aniline you will be getting it. 1 carbon atom is decreased. We can say that. Clear? So it is used for the descent of series. Again and again I am saying you. Now we can also produce by the reductive, that is amination of aldehydes and ketones. That is when we will react aldehydes and ketones with ammonia. In simple words we can say that. Clear? That is RCHO plus HNH2. We can say that. Clear? Upon heating, we will be heating it. Alright, why we will be heating it? So that water will be removed from here. Clear? Water will be removed from here. So water is removed from here. So that is when the water is removed, what I am going to get it? See here. That is RCH, here double bond NH. See, RCH double bond NH. See here. RCH, C double bond. So C double bond NH. So this is an imine. You got it. You know that imines are not stable. Imines are not stable. Imines are. So hence what I need to do? How will I make stable? What I want the product? I will go for reduction. H2/Ni and heat it. Reduction. Alright, catalytic reduction I will be going for. So when I will go for catalytic reduction, what will happen? RCH2 and H2. RCH2 and H2. I want amines. I want the product amines. How will I get it? That is, I will be going for reduction. I want hydrogen, isn't it? So hence here the double bond will be replaced by a single bond. How? By adding hydrogen here and here. That's it. So it is RCH2 and H2. In this way you will be getting it. So you got here, that is nothing but primary amines. If you take ketones, If you do the reaction with ketones, you will be getting nothing but secondary amines. Let us do it and see. Alright, let us do it and see. I think you have written this one. So RCOR. So what you will be getting is that same thing, water is removed. So RCR here, that is, let me put here R, another one. Alright, double bond NH. Let me bring it closer, this one, double bond NH. Alright, if you don't understand, then I will put R and R dash. Here R and R dash. Now it's clear. Now see, so what is going to happen? RCR, alright, RCR dash. Alright, RCR dash is there. Then what I will be getting it? That is nothing but here CH to balance this carbon atom. CH, then NH2. What I got? Secondary amines, not I'm saying secondary amines. I'm saying that is nothing but in the secondary carbon atom the amino group is attached. In the secondary carbon atom the amino group is attached. It's a primary amines, but in secondary carbon atoms it is attached. For example, it can be your isopropylamine, for example, or you can be your nothing but what you can say, isobutylamine. We can say that, anything we can say. So in this way you will be getting it. Fine. So you can have the same alkyl group, or you can have different alkyl group. Here I have taken different alkyl group, so to say. Now next, after that is we can prepare amines by Gabriel's Thalamide synthesis. Another very important reaction. Gabriel's Gabriel Thalamide, Thalamide, Thalamide synthesis. Gabriel's Thalamide synthesis, we can say that, or Gabriel's Thalamide reaction. Now what is Thalamide? First of all, Thalamide is this, amide it is. So from the thalic acid we get it. So what is thalic acid? COOH, you know that, isn't it? This is your thalic acid. Clear? Acha, what will I do? I will remove this 2OH group, and instead of that I will put NH. It becomes what? Thalamide. This is called as Thalamide. THALIMIDE. This is your Thalamide. We can say that. So when Thalamide reacts with KOH, alcoholic KOH, what will I get? I will get potassium thalamide. You can take NaOH also, no problem. So CO, and here it is NK. This is your potassium thalamide. This is known as potassium thalamide. I got it. Now next, it is an ionic product, potassium thalamide. That is K plus, and this whole thing is minus. It's an ionic product. Remember it. So ionic product means it becomes very easy for us because the ions can be interchanged. Understood? So ionic product is very easy if it becomes. Now I'll react with RX. Any amines which I want. Suppose if I want methylamine, I'll be using methyl chloride. If I want ethylamine, I'll be using ethyl chloride. If I want benzyl, if I want aniline, I'll be using C6H5Cl. We can say that. Clear? So I can use what you can say any that is amines, but better is to take alkyl amines, because again I repeat, aryl halides does not undergo substitution reactions readily. We know that. Aryl halides are less reactive than alkyl halides, so to say. Clear? So it is better to take, that is nothing but here alkyl, that is halides to take. Any alkyl halides you can take it, whatever the amines you want to prepare. If you want to prepare methylamine, take methyl chloride or methyl bromide or methyl iodide. If you want ethylamine, take corresponding ethyl chloride, ethyl bromide, ethyl iodide. So any particular that is amines you need to prepare, you take it, that particular one. So what is the product I am going to get it here? The product will be benzene ring CO. Instead of NK, I will be getting it as NR. And here it will be minus KX. K goes with X to form KX. N goes with R. So it is NR. We can say that. Now what should I do? I will be reacting with, that is nothing but dilute HCl. Dilute HCl means we will be taking water and we will add little bit of HCl to it. That is dilute HCl. Under pressure, I will be doing it. So dilute HCl, what I said you, we will be taking water and we will be adding little bit of HCl to it. That is dilute HCl. So basically I am reacting with water only. Acidulated water I am going to react with it. So hence From water you will be getting hydrogen. So hence what I am going to get it is nothing but RNH2 you got. Plus, let me rub this one, then I will have the space, plus what will I have? The secondary product. Here the secondary product is COOH. COOH, that is your phthalic acid. And this is your primary product, that is your amines, we can say that. Clear? So in this way, this is called as Gabriel's Thalamide synthesis. You will be getting it. Clear? That is Gabriel's Thalamide synthesis. So from the Gabriel's Thalamide synthesis, we can prepare the primary amine, so to say, we can say. Now, you can also prepare it from alcohol. This is an industrial method from alcohol. So alcohol reacts with ammonia. You've done in alcohol chapter this one. Alcohol, when it reacts with ammonia, HNH2, got it? In presence of Al2O3 at 623 or 625 Kelvin, whatever you can write. Got it? So Al2O3 acts as a dehydrating agent. It removes water, and hence this HOH will be removed from here. Okay, you can take. So hence what will I get? You will get RNH2 plus water. Got it? So this method is an industrial method for the preparation of amines. We can say that. It's an industrial method for the preparation of amines, we can say. So 623, 625 in certain books also written 633 Kelvin also. It has been written in certain books. That will do. So if you see, compare this particular reaction with the other reactions which you have done it. So here the yield is more. So hence this reaction is preferred in the industries for the preparation of what you can say amines, so to say. Thank you.